Hello, this is video 1 for Professor Pastor's Materials for Industry class by Mariella Manipol at Tidewater Community College. So I chose my engineering disaster on the 3 Mile accident or the 3 Mile Island accident, the worst nuclear disaster in the United States that led to major changes in nuclear power plant regulations and public opposition to the industry. So the location is on the Susquehanna River in Londonderry Township, Dauphin County, near Harrisburg, Pennsylvania. On March 28, 1979, at 4 a.m., the Unit 2 reactor, TMI-2, of the 3 Mile Island Nuclear Generating Station had a partial nuclear meltdown. Here's a photo of the nuclear generating station. Here we have newsmen and spectators standing in front of the main gate of the 3 Mile Island Nuclear Generating Station in Middletown, Pennsylvania on April 2nd, 1979. So here we have our system. As you can see, the cooling tower, the pumps, and the reactor building where it is all connected. So for mechanical errors, the main feed water pump tripped. Feed water has a cooling effect that turns into steam, which helps generate electricity. While the feed water pump is experiencing issues, feed water is unable to get to the core. Without feed water, the core will get dangerously hot, even with the cooling system activated. The pilot-operated relief valve, also known as the PORV, this valve opened up to release pressure due to the lack of feed water. It releases pressure due to pressure buildup. It is designed to prevent overpressure in the reactor. The control rods dropped in an attempt to slow down the reactor from overheating and overpressurizing. Some human errors. The operators noticed that the emergency feed water pump light came on, an indication that the reactor is not getting enough feed water. They did not notice that no water was running through the pumps. One of the lights was covered by a yellow maintenance tag, and the other light was mysteriously missed. So this means that the secondary water loop, the clean water, will boil dry, which activates the emergency core cooling water system, attempting to flood the overpressurizing/overheating core with water to cool it. So the operators decided to turn off the emergency cooling system, thinking the blocked emergency pumps were flowing with water and did not want to overflow it. The operators did not receive any indication in the control room that the PORV physically resetted itself like it should. This was for the reason that, because the light for indication was covered up, they would not have known the fact that the PORV did not reset itself. Pressure will continue to be released. For the next 2 hours and 20 minutes, the PORV remains open. A signal was shown to close it, not that it was actually closed. It resulted in 32,000 gallons of coolant water to escape the system, which is 1/3 of the cooling water. So then the core starts to overheat. As the core continues to overheat, contamination got into the cooling water. It made contaminated steam. The PORV is still not reset, so then steam gets out. Here are some photos of the blocked control room buttons. So the PORV failed 11 times before the system. There was a nuclear power plant in Ohio that failed with the same type of PORV in a similar fashion. The manufacturers of the PORV had made these PORVs There was another facility in Ohio that had the same manufactured PRV that failed. So there were also poorly designed and maintained control rooms with tags covering lights and indicators, alarms that were constantly going off. The operators did nothing whilst the alarms go off. And then there was also minimal build up on valves and around the safety crucial valves. So in total, it was a lack of maintenance. So here's some pictures of the poorly kept PORVs. So some information during the disaster, low-level radiation alarms blinking in the unoccupied containment building. So I don't know what the operators were doing, but they were definitely not doing their job. Fuel in the reactor core was uncovered by water for more than 38 minutes. 2 hours, 2.5 hours later, the operators go check on the block valves, the redundant PORV. The block valves were shut, coolant stopped flowing out of the system. The emergency reactor cooling pump was turned back on. They turned it back off due to heavy vibrations, and temperatures rose to almost 4,000 degrees Fahrenheit and 2,200 degrees Fahrenheit. Hydrogen gas started to develop, and thus the fuel rods started to melt down. So several areas encountered high levels of radiation. On March 28, 1979, at 7 a.m., just 3 hours after there were mechanical errors at 4 a.m., the site was declared a disaster. 800 rems per hour were released in total. On March 29, 1979, contaminated cooling water was discharged into the Susquehanna River. On March 30, 1979, at 7 a.m., a supervisor transferred krypton and xenon gases to the decay tank. So 2.5 million curies of radioactive decay were made. 1,200 millirems per hour were above the vent stack, but free hydrogen isotopes bonded with oxygen and made water, so there were no alarming instances of explosion. So basically, the disaster fixed itself. The bubble dissolved. Krypton and xenon gases will not really happen as toxic to humans. So the entire disaster, studies have shown, resulted in no health effects at all. So because of this incident, the NRC established safer operations, so in total better guidelines. There was emergency preparedness and communication, operator training, so we don't have lazy, unprepared operators. What? Here we have some more guidelines. How did it change the field of engineering? So it definitely focused on more human controlled engineering and just making everything safer. And there was procedure after procedure with everything. And my citations.